This is going over the questions we didn't get to in lecture on compound transistors. So questions 2, 3, and 4. So question 2 was about an input stage. And I gave you the circuit. And I've given you this input stage, and you can tell that the inputs are the VI plus and VI minus. And question was, how could you use a compound transistor to improve this stage? And the main job of an input stage is a high Rn. So if you wanted to give this a higher Rn, you could maybe replace these two transistors with something. So if you go over to Rn, here's a big Rn. These are all the same as a single transistor, so replacing these with any of these others wouldn't change your Rn. But here's another one. So you could use degeneration, which would be, this would be the degen solution would be, let's just copy this for a second. So the degeneration solution would just be to add resistors here. This node is actually in a well-designed input stage. This node hardly moves at all. It's like it's an AC ground. So putting resistors here is, you are actually degenerating this transistor by putting a resistor here. You're degenerating this transistor by putting a resistor here, and then this node doesn't move like an AC ground. So you can see that the resistor goes from the emitter of the transistor down to a ground. Okay, so that's one possibility. The other possibility is, say that you saw over here that, so that's the degeneration solution to give it a higher Rn. There's also the Darlington pair solution. Oops, this is quicker. Oops. There we go, finally. So you could replace those transistors with a Darlington pair, which would be, didn't leave myself much space. Try to draw this side a little better. And now, these are two different ways to increase the Rn. The difference is that degeneration kills the gain. So even though the input stage is not, its main job isn't to provide gain, if it provides a little bit of a gain, then it's actually helps out the gain stage. So either that gain stage doesn't have to be as much, or it increases the overall gain of your op amp. So degeneration kills the gain, so that's a slight drawback. So this right here, this will give you big gain and a big Rn. So a bigger gain and, well, same gain and a bigger Rn. So that's a good solution for the input stage. Okay, so those are those two. And the next question was for a gain stage. What's the maximum gain transistor that you can make? And none of these change GM. And remember that the transconductance is what was I going to say? So the You can't change the transconductance very easily, but you can change R out. And so remember that the gain of a transistor is your transconductance, which is going to be either little gm or minus little gm unless there's degeneration. So this doesn't change very much, so you target that. So looking over here at R out, got a few with, I mean, that's a, let's not say that one. This is going to give you a little bit bigger than a single transistor. This is smaller, so that's going to drop your gain. This is giant, so that looks like a promising one, but this is the most giantest. And let's look. So this was our initial version of your common emitter. And then we found that if we increased this resistance, then this whole gain went up. But let's do that. And we're going to use gain boosted. So what that looks like is it has to be cascoded. And then here you have and let's leave the bottom as it is and see if that really increases the gain. So I replaced the resistor. You know you can replace it with a single transistor to make it an active load, but then I replaced that active load with a gain boosted transistor. And the question here is if this really increases your gain. So what you have right now is your R out. If you're doing the quick method, this becomes a ground. So you have two paths to ground. And going down, you see RO. Going up, you see whatever the gain of your gain boosting amplifier times your GM of this transistor. In this case, this is BJT, so it's RO R pi. And what happens is this is much bigger than RO, so this actually equals approximately RO. So you lose the effect of making this resistance, this load resistance, making it look really big, because looking down, you still just see an RO. You lose the advantage of using gain boosting. So what you have to do to get your maximum gain is you have to gain boost looking up, and then you also have to gain boost looking down. And now your R out will be approximately, if you assume the amplifiers and the ROs are the same, AVGM RO R pi over 2. And this is going to be much bigger than this R out. Assuming that the AV and the GM cancel each other out, now you've got 100,000 times 10,000 divided by 2, which is going to be much bigger than this RO here. So that's for the gain stage. And then the last question was about an output stage and what you might use there. And an output stage, I think I wrote common collector, did I? common collector. So here's your common collector. And if if you're going to replace this with something, you still need to show it an emitter. The emitter shows that the low resistance. Remember, for an output stage, you want a low R out, which just means that if something asks for current, it doesn't mess up V out much. So you're looking for a low R out. That's not low. That one looks low. That one doesn't work. That one doesn't work. That one doesn't work. So Zickley pair is R out. This is looking at the collector, not at the emitter. I'm sorry. This is misleading. My bad. So there's actually two you can use here. Two that have an emitter connected to. This is confusing. Okay, so how about this? We'll make it low R out and a good current drive. That's often a requirement for an output stage. So something that can provide a lot of current. And the one that can provide a lot of current here are these two. And the other two have no current advantage. So you could make your make it either into a Darlington pair but now you have a 2 VB on shift between V in and V out. So V out will equal V in minus 2 VBE on. Or you can use a Zickley pair, which PNP and it sees a collector here, but this is an emitter right here. So it still shows you a pretty low V out. It just has to change this voltage just a slight amount, and this thing will conduct a lot more current, which will make this conduct a lot more current. So pretty low V out, R out. So either one of these gives you extra current. The difference here is that this drop right here is just 1 VB on. So V in minus VBE on instead of 2 VBE on. And those are the answers to the questions from lecture today.